Hey, Sex Math, Course 3. Welcome back to Lesson 8. Lesson 8 is on perimeter and area. So as a review of what these are, perimeter is the distance around an object, while the area is the measure of the surface. So when we're writing those down, we kind of think about that as a room. Take a look at your room you're in. The perimeter is represented by the baseboard. So you probably have a little piece of trim that goes around your perimeter of your room. That would be perimeter, so the distance of that. And then the area would be the amount of carpet that's on the floor. If we had a tiled floor, it'd be the little square tiles. So as we look at these, perimeter is a linear measurement, where area is going to be a measurement that is squared. So let's look real quick at what I'm going to want to see you do for area. In order for you to do area, I'm going to want you to write down the form. Let's draw the picture first. So I want you to draw the picture. I want you to put the formula. I want you to define your variables. And then I want you to substitute and solve. So we're going to start with rectangles. So if we had a rectangle that was 2 by 3, we would draw it. Area equals length times width. Length is 3. Width is 2. Area equals 3 times 2. Area equals 6. Okay, so now let's look at the labels of what we have. If I had to do perimeter, I would have 3 feet plus 2 feet plus 3 feet plus 2 feet. 3, 6, 7, 8, 9, 10. So this gives me 10 feet. We just added, kind of like apples and, 2 apples plus 2 apples is 4 apples. When we did the area problem, I'm going to skip some of it. I'm going to put down here 3 feet times 2 feet. So you can see here you got 3 times 2, and you got feet times feet. Commutative property says I can switch. Associative property says I can make different groups. So this is 6. Feet times feet is feet squared. I also can look at that visually up here. I have this rectangle, that is 7 by 3. So here's my rectangle. So as I look at that rectangle, perimeter, we can call this units when there's no label, but perimeter is 7 units plus 3 units plus 7 units plus 3 units. 7 and 3 is 10, 7 and 3 is 10, 20 units. And when we add those up, kids will sometimes go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What they didn't do was they didn't add the actual sides. Each corner has 2. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see going all the way around it, it is 20 units. Now if we wanted to do the area, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Area is length times width. I have the picture drawn. Length is 7, width is 3, area equals 7 times 3, area equals 21 units squared. Because each of the units we're measuring now is a square. Let's look at one other aspect. If we had problems like this, the first thing we're going to want to do is be able to identify sides we don't know. So as I look at this one, if I were to identify sides I don't know, if this side from here to here is 8, and I slide this piece over, you can see here is 5. Which means this piece here has to be 3. 5 plus 3 is 8. All of the parallel lines are related. So we can do the same thing now with ones here. This line here is 7, and this line here is 5. So if I took the 7 down here and the 5 down here, means I have a side that is 12. 12. Now that I have all the pieces, I can decide how I best want to break them up. So we're going to break these up a couple different ways. One way I see, let's start with this one right here. That box there is a 7 by 3. Well, before we move it, let's draw the other part. This piece here. So one option is this option here. A 7 by 3 and a 12 by 5. So if this piece is 21 and this piece is 60, this entire shape should be 81. Well, if we're not set yet, I'll use another color. I'm going to use blue. Look at this piece here, and maybe this piece here. If I were to slide these pieces out, let's see if we can get it. There we go. And there we go. I have a piece that is 8 by 7 and 5 by 5. Area equals. $25 plus 56 is 81. Again, 81. We might have one more way that I can see here to do this. If I took that entire shape over here, that entire shape was 12 by 8. And I look at this little void piece here. This little piece here was a small 3 by 5. 3 by 5. So if area equals length times width again, (96) minus 15, because that chunk is cut out, I still get 81. Whoa. 81 and 81. There are other ways we could do it. I could grab a highlighter here if I wanted to. We could have said, hey, you know what? Here's a piece, and here's a piece, and here's a piece. And we could have divided it into 3 pieces. But as long as you define what your pieces are, you should be good to go. At that point, guys, you got practice problems A through F. Come back after you've tried them, and we'll work on those together. Please make sure you show all work when it involves area. See you in a little bit. All right, let's take a look. Let's take a look at those practice problems, see how you did. First one. Jared's placing baseboards in 1-foot square tiles in a 12 by 8-foot room. Ignoring doorways, how many feet of baseboard and how many tiles does he need? Guys, we're looking at, here's a practical application. If you own a house, when you own a house, this is stuff we're going to have to do. So first, baseboard, that's going to be going around the place. So that's my perimeter, 12 plus 8 plus 12 plus 8. That's adding up 12, 8, 12, 8. So 20 plus 20, 40 feet of baseboard It's not just asking how long it is, how much baseboard, and then we simply say area, length times width. If length equals 12, width equals 8, area equals 12 times 8, area equals 12 times 8 is 96 feet squared. Now, because the tiles are 12-inch tiles, or 1-foot tiles, that's exactly what we need, is 96 tiles. But what if the tiles were 6-inch by 6-inch? Would you double it? Six by six, 6 by 6, 6 by 6, 6 by 6. It would actually be by 4. So if they were 6-inch tiles, every square foot is going to have to be these 4 tiles. But that's going to be down the road, and we'll talk about that with scale factor. Here's a hint to one of your other ones. If the scale factor is 2, my area scale factor becomes 2 squared, which is 4. So to go from 6 to 12, we multiply this side by 2. So the area has to be multiplied by 1, 2, 3, 4. Interesting as we look. That kind of comes to this one right here. So find the perimeter in the area. Perimeter equals. Now as I look at these, the dimensions are centimeters. So I like to put centimeters in here so I'm not writing it all the time. So perimeter equals 3 plus 4 plus 3 plus 4. Perimeter equals 7 plus 7. Perimeter equals 14. So perimeter, perimeter equals 21 plus 21. Perimeter equals 42. So there's our perimeter. Draw the picture. Area equals 12, and we know that would be centimeters squared. And here, area equals length times width. If length is 12 and width is 9, area equals 12 times 9. Area equals 108 centimeters squared. Which, question D wants us to analyze these. It says the length and the width of the rectangle in C are 3 times the length and width of the rectangle in B. So what they're saying is 3 times 3 equals 9. And 3 times 4 equals 12. Well, what about the perimeter? If we were comparing the perimeter times what number is the perimeter? And if we look at this mathematically, the perimeter for the first one is 14 times x, because we don't know, equals 42. We remember our algebra, divide both sides by 14. X equals 42 divided by 14. Pretty sure that's 3. What about the perimeter? What about the area? As I look at the area, so the perimeter of A, I guess this would be D, the perimeter of B, is the perimeter of A times 3. Same as the side. So what about the area? Did we multiply the area by 3? So the area of the one was 12 times what? We'll say x equals 108. Divide by 12, divide by 12, x. 36 divided by 12 is 3. 100 divided by 12 is 9. So as we look at this one, the area of B is the area of A times 9. That would be a good answer when we're asked to analyze those. Now, one of the things that's fun about that is this fact that, just so you know, if I have a scale factor of 3, and that's exactly what we have here, because 3 times 3 is 9. That makes it a scale factor. The perimeter scale factor stays 3, because it stays the same as the scale factor, but the area scale factor is going to be 3 squared because it's the scale factor squared. That's a topic that's going to come up a lot in this book. And if we want to pause and really think about that, the volume scale factor would be 3 cubed. It's the scale factor cubed because we multiply those numbers 3 times. You know, as we look at what happens here, going from the 4 times 3 to get the 12, we multiply by 3 and by 3. That's why the area becomes 3 squared, which is 9. So, last problem we have, the one where we have to break it up into pieces. I'm going to choose just one way to break it up. Oh, hold on, not yet. Sorry. D. Length E, placing 12 tiles. We come up with this shape here, 12 by 1, E. Now the book wants to know other ways we can arrange those tiles. Guys, a 1 by 12 is going to be the same shape, just rotated. So we can't do 1 by 12, but what we're looking at is we're looking at the factors. 1 times 12, what else? 2 times 6, or 3 times 4. So he could make a 2 by 6 rectangle and a 3 by 4 rectangle. Both of those. Guys, you can't say 2 by 6 and a 6 by 2 because it's the same rectangle. They want different ones. Which takes us now to the last one, F. If nothing else, hopefully you got your sides figured out. If I look at this one here, this is 13. So if that piece there is 13, and I bring it down with the parallel sides, and this part is 3, then this part here has to be 10. So this side is 10. Same thing here, looking at the perpendicular sides. From here to here is 14. This side is 14. This side is 11. I want to see it another way. If this is 14, and this piece is 11, this is what's missing. It must be 3. So this piece here has to be 3. Now what I want to see for your drawing for the area, you don't have to draw the original for this. What I want to see is I want to see that you have the 2 pieces to help you solve it. I'm going to solve it only once, and as I look at it, if I put my dot there, it's 11 by 13. That's this piece here, 11 by 13, and a 3 by 3. So area. Times 11 is 143. So 143 plus 9, I get 152 units would be feet squared. Now, as I look at that, you might have went like this. This piece here is a 3 by 14. Combined with a 10 by 11. Say sometime here, multiply, this becomes 42. This becomes 110. That's 152. I just checked my work to see if I was right. Or you might have went 13 by 14. A 13 by 14 and subtract from that a 3 by 10. So 3 by 10 is 30. 13 by 14, I don't have that one memorized. 12, 4, 1, 4, 182. Makes sense. Because 182 minus 30 is 152. So multiple ways to check it. Don't forget we also had to do perimeter. I would do perimeter the way I trace it. So 11, 13, 14, 3, 3, 10. 11 plus 13 plus 14 plus 3 plus 3 plus 10. There are 1, 2, 3, 4, 5, 6 sides, 1, 2, 3, 4, 5, 6 numbers. It's amazing how many times we don't add all the numbers. 10, 14 plus 3 and 3 is 20, plus 10 is 30, and this is 24. Add it together, 54 feet. 54 feet. Perimeter. They do take some work, but you guys have the skills. You should be okay. That's your lesson. God bless you guys as you work on your homework.